Well, and now to relax our brains a little bit, let's see something more visual. We have Juan Alberto Ramírez. He's a professor of the Automatic and Design Group of the University of Pontificia Bolivariana. He's going to give us a demo of the robotics program. Oh, welcome. Give him an applause, please. Thank you. Good afternoon. The purpose of this talk, basically, it has two parts. One is to tell you why we think it's a good idea to make robots. Why do we feel it's a good idea? And also we want to show you one of the projects that we are most proud about in the university, which is this small blue robot, which is the result of many hours of work by our students. During this presentation, we're going to see a little bit of the work by the robot, how he works. He's going to be drawing as on, and also we're going to be telling you a story of real cases that we have seen at the university. So we're going to advocate 3 points during this presentation. The first one is our development depends on what the universities are able to achieve, especially because of the very important role of universities in our society. They are the ones who are training people. They are the ones who are making the future professionals to have the qualities that they have. The other idea that we're going to be advocating is that it's not enough being a technology user. While we can be good at using technologies and we want to do good with that, we also have to learn how to develop it. We're going to tell you a story about how we went from being users to be developers of technology. And finally, we're going to try to talk to you about why making robots is a good idea. Especially, we're going to do it from 2 points of view. We think it's very formative, and it puts us in the position of developing technology. And I have an example for that. The images that we're seeing here are images from a competitions where we had the opportunity to visit. We were guests. We were not participating, but we were guests, and we were seeing what students of elementary and high school were doing in terms of robotics. This was last year, and what we saw is that when we work in robotics or similar activities, we find an amount of values that transcend the activity itself. It transcends the fact of making a robot, but besides that, it makes us getting some values that are transversal to any discipline. So it's important working robotics because it's really exciting. If you see a robot such as this one and you see how it works, you see when something is moving, we are getting passionate about it. We are very passionate about seeing it working. We also see that when a person gets into this world of robotics, regardless of how complex or simple the problem is, that person realizes that they have to face the problem using creativity. Is completely necessary. Otherwise, if you don't solve the problems or use creativity, there will be no success in the process. And the other thing is, as you will see, it's necessary to work as a team. For example, a team such as this one, which is now working, and we see that it works, and we're very satisfied about that. This was possible only through a work by a team. Only through teamwork of a large team is that it is possible to achieve a prototype that works just like this one is working. So a working team is very important. I am telling the story, but the people who are behind the scenes are very important. Here we see how the robot is working. You can see a close-up. You can see many details. The way we made it and how it is working right now allows us to touch, see, learn, see what is happening inside. We did it on purpose. We could have used some materials doing a prototype such as this one, but we said, why we should create a robot where we can see what is happening inside, and that's exactly what we did. We tried to make it visible, to learn during the process. Now we can go back to the presentation. Okay, this is Okay, this is not my presentation, but I'm going to go on with my story. It's necessary to solve problems with creativity, working in teams, thinking in an orderly manner, and very important, if you want to have a happy ending, you have to face frustration. This is very necessary. You're going to start working on something, you are going to create a prototype. The prototype is going to fail. And it's very important for you to know what happens is if, for example, the robot stops working right now, we have to face those challenges. So the fact that we're achieving those strengths make it possible for any people who have that strength are necessary to be a part of that team. If you're an entrepreneur, if you work in research, if you are working on innovation, you need people with those characteristics. So when we deal into this technology, when we start developing technology, we have the capacity to develop solutions in this context. If we are in Colombia, we should be able to create solutions depending on what we need. And during this process, we should be able to destroy technological bridge. At the university, we created a robotics manipulator. This technology that is ready to be used. It's not a simple technology to use. So when you realize a team like this one, when they integrate into the industry, what happens is the companies try to go through the steps 1 and 2. You train the people, and with that, you have enough to implement a solution. But we say, okay, let's take some additional steps. Let's work with a mathematical model. Let's do a simulation. And after that, you're doing a simulation of the process here. Let's try to implement. So let's take the step. Let's do it in a more paused way. Let's get into the solution of the problem, and then we'll try to implement it in the real world. So what we did with this one, after we got trained, we learned to work with the team. We started the mathematical model. We did some simulations that showed the mathematical model, and then we tested it on the field. So we have an industrial equipment that is working. And what we were able to do, we were able to develop, we were able to be technology users, but that doesn't put us in a role of being able to develop it. We also took additional steps. We create robots, we made robots, so we're taking the steps where we not only use the technology, but we know what's inside it. And we have 4 examples here that we have developed in the university. We have a Cartesian table, it's a type of robot. We have a submarine robot. We have a parallel robot. And we have our equipment, the serial manipulator. These are examples of the equipment that we have developed. These are examples of development and technology, and these are examples that allow us to learn where it's inside the equipment, and during the process, learning a lot. Let's talk about the blue robot. Like I said earlier, we have a working team that is very large behind the development of this robot. This is not one single person's work. We had a total of 9 people working with us, 3 professors, 6 students, in different disciplines of engineering, and they were able to make this equipment work. What we're seeing here is the result of students who are finishing their process of training. They worked on the thesis developing this robot, and this is the result. What we did was we did a design, we did some sketches, 3D modeling, we did plans, construction, and that construction was done mostly using traditional processes. We did a whole control and electronics control. We have a control interface. We have a software that controls the engines. We have a series of equipment that makes the robot work properly. And I lost my video, but before the robot was working, we did some testing. We had a lot of problems making it work, and finally we were able to make it work correctly, and we were able to get the product that you saw. Maybe if the cameras do a close-up, you will be able to see what the process is, what the status of the process is. What we have as a perspective for the future is, since we realize we are able to develop robots and making them work, one of the perspectives for the future for us is submarine robotics. In our past work, we have been able to develop submarines and also robots, and we have tried to put them together, to work together. So we expect that within 4 years, we were able to finish the development of a project where we're going to create a submarine robot that is able to go down 500 meters and that will allow us to explore the bottom of the ocean in our country. This project is just beginning right now, just started in January, and it will last about 4 years. And during the process, we're going to train about 30 people, undergraduate and graduate levels. And finally, we have a tool that we developed with our own technology. This project is sponsored by Ecopetrol, called Ciencias. And as executing entities, we have the University Pontificia in Medellin and also the National University of Colombia. And this is what I wanted to show you. Our team, our equipment, our development, what we have been wanting to do, and most importantly, what we are capable of doing with our undergraduate students. Thank you very much.